Every single person has listened to music in one way or another. It's a consistent part of every culture. Two people of separate languages can bond by listening to music together. Kids are taught from early years that music is important and it should be valued. Even deaf people can listen to music by feeling the vibrations off of speakers. So, even though we all relate to music, why does nobody ever ask, why does this work? Why does this instrument sound like this? Why is this one quiet and why is this one loud? These are questions I've been asking myself, and I thought it was about time that I found the answer. And I also thought that it would be nice to share it with everyone too. To get down to the point, the most fundamental thing that we need to look at to understand music are sound waves. Sound waves are patterns. They're created by a source when it vibrates, like when someone talks or when someone plays an instrument. Right now, as I'm talking, the vibrations from my voice are disturbing the matter around me. The matter around me that got disturbed is disturbing the matter in front of it, and the matter in front of it is disturbing the matter around it, and so on, wherever my voice reaches. This chain reaction created by the disturbance from vibrations of my voice is what we call sound waves. These sound waves can not only travel through the air, but they can also travel through things like water or gas. They are the different mediums of sound waves. To get a further look into what sound waves are, we should look at a diagram. If you've never seen a sound wave before, it looks something like this. It has lots of peaks like a mountain or like waves on the ocean. There's also something called the midpoint, which is the absolute center between the 2 points of a wave, which are the highest point, the crest, and the lowest point, the trough. There's also something called a wavelength. It's the top of one wave to the next. One of them is called a cycle. And there's also the amplitude, which is the distance from the center point to the crest. Now that we know a little bit more about how sound waves work and how they function, let's look a little more in depth about them. The first thing we're going to look at is the importance of amplitude. The reason why it's so important is because it's actually the thing that determines the volume of the wave. Say it looks something like this, where the peaks are really high and the trough and the crest are really far from each other. This would be a loud wave. But say the wave looks something like this, where the waves are softer. The trough and the crest are closer together. This would be considered a soft wave. To get a better understanding on how amplitude works, I wanted to give a demonstration. This is a viola. It has strings, and when you pluck it, the strings vibrate. If you look close enough, you can see an example of what a sound wave looks like on the string. If we look at it again, we can see that when I pluck the strings softly, the waves are much smaller. But when I pluck them more firmly, the waves are much bigger, showing the difference between low and high amplitude. The next thing I want to look at are wave frequencies. Let's take a look at another diagram. A wave frequency is the number of waves that pass through a point in a given amount of time. The one being drawn right now has many waves. They're all close together, which means that more are passing through in that time, making it a high frequency wave. The one to be drawn right now has less waves, which means that less waves are going through in that amount of time, making it have a low frequency. This is the difference between a high frequency wave and a low frequency wave. Understanding the difference between high frequency waves and low frequency waves is actually important when it comes to music, because the frequency is actually the thing that determines the pitch of the instrument. The higher the frequency, the higher the pitch. The lower the frequency, the lower the pitch. Another reason why wave frequencies are so important is because they can be used to find the wave speed, with the equation speed equals wavelength times frequency. Now that we've seen the many fundamental parts of sound, let's take a look at something a little bit more complicated and more integrated into music, something called standing waves. A standing wave looks something like this. There has to be a beginning and an end to the wave, these points being called nodes, which mean no movement. The wave on the inside has to be vibrating at a perfect frequency so that it starts at the beginning node and ends at the end node. If it does, the wave will bounce off the end node in the mirror direction, creating something that looks like a standing wave. The space between the standing waves are called antinodes because it's the place with the most movement, and the places where they intersect are also nodes. These specific frequencies of vibrations are called harmonic frequencies or harmonics. These are a few of them that are used in music. There's the first harmonic or the fundamental harmonic that has one wave. There's the second harmonic that has two waves, the third harmonic that has three waves, and the fourth harmonic that has four waves. To close off, I wanted to demonstrate the first three harmonics. I hope you enjoyed.